Now, this is just really just a cool skill to have if you like enjoy math, like factoring using the distributive property. Because what this leads to is ending up being able to solve some pretty cool problems. Like if you picture, a rocket launching, it actually, would have a goal to hit at a certain point or land safely. Or if it was, a missile, you'd have a target you'd be going for. And no, this is not an endorsement for war. It's just saying that these things have real applications, and that's kind of cool. So factoring a polynomial. Now in the last section, you were taking something, and you were just saying, oh, okay, this is made up of, a bunch of numbers times itself, and then times x times x times x, and so on. But what this means is that we're going to be starting with something made up of multiple parts, and then later on breaking it up to totally factored forms. But right now, we're dealing with things that might just have a couple terms for now. Now, if I look at this, I see 12x squared plus 16x. Now, I'm going to write this in red because this would be like the wrong way of doing things. I could start to factor something. I know that 2 fits both into 12 and 16, so if I wanted to pull a 2 out, well, what number times 2 gives me 12? So 2 times 6. So I'm factoring out a 2 from 12 to write 2 times 6. But I didn't talk about x squared, so I'm just going to write that. And then I decide, well, what can be factored out from 16? Well, 2 did. Well, 2 times what number gives me 8? And there's my x over there. So I'm looking to, pull out the biggest possible value out here so that I'm left with something in totally factored form, so that this is as simple as possible on the inside. Now, the reason I'm showing you a wrong way is because I'm still able to pull more out from 6 and 8. Because both of those numbers could be divided by 2, I could pull out another number. So I would definitely steer clear of doing it, a long way like that, and try to think about what's the greatest common factors. So for 12x squared, I know that 12 is made up of 2 times 2 times 3 times x times x. And then 16 is made up of 2 times 2 times 2 times 2 times x. But really what I'm looking at, and I'm saying to myself, well, what's the biggest number that goes both into 12 and 16? Because I'm always dealing with those coefficients first. And the biggest number that fits into 12 would be, so if we did this the lengthy way, we'd say, well, 2 and 2 are showing up both places. So there's that 4 that I could factor out. So I'm going to write 4 over here, because so far, that's my greatest common factor. Now, until you get to the end of the problem, it might be a little confusing, but I'm basically pulling a term out, and I'm going to be left with that same pattern in here where it's something plus something else. Now we've totally dealt with the variable, the coefficient, so now let's deal with the variables. X squared is made up of x times x, while x is made up of just 1x, so the greatest I can pull out from this is going to only be x. So there's me pulling 4x. Now, I'm going to erase these parentheses, and I'm going to make them actual things now. But what this means is that I'm going to have some term plus another term remaining on the inside, because I'm factoring 4x out from the 12x squared plus 16x. So really we have to say 4x times whatever this is would have to be 12x squared. So first, 4 times 3 would give me 12. And then x times x would give me x squared. And let me just prove that to you real quick. Here's 4 times x times 3 times x. 4 times 3 is 12, and x times x is x squared. And then on the right side, I pulled out 4, and the only way I'm going to get 16 is doing 4 times 4. And then the only way I'm going to get x is by doing x times 1. I wouldn't have a variable showing up there. So it might feel strange, but that means that this part is all done. Now lastly, I'm going to scan through this and make sure that the greatest common factor of these parts is really just 1, meaning that I can't pull anything else out. Well, sure enough, I can't pull anything else from those two terms. And so this problem is completed. This line of math is equivalent to what we started with, and we have just used the distributive property to factor each polynomial out. Now, for this problem, I'm going to put the word check. And I want you to check this just to prove to yourself that it agrees. Because I think by working this out backwards, by going back to what we started with, we're going to feel more confident that this is a real deal thing. So 4x times 3x gave me 12x squared. 4x times 4x gave me 16x. Oh, cool. You know, that's what they mean by the distributive property. It's like I'm doing the distributive property in reverse to check out this problem. All right, let's check these out. Now we got 3 terms over here, 2 terms here, 2 and 3. So maybe this can be used, you know, depending on the number of terms there are. So between 8 and 4, the greatest common factor is 4. Between x squared and x to the 4th, this left term has 2 x's, this has 4, and of both of them I can pull out 2 at the most, so I'm going to write 4x squared. I'm going to open up a parentheses. I see that there's a plus sign, and I know there's going to be something on the right there. So 4 times what number gives me 8? Well, that would be 4 times 2. And then x squared times what gives me x squared? Well, even though you want to write something here, you don't need to write anything with x, because really, you've pulled out as much of the x as possible. Now we have 4 times something to get that. Well, the only number that will work over here is going to be 1. And then x squared times something that gives me x to the 4th would have to be x squared. Now you can see why I didn't bother leaving that 1 there when I wrote it. I only wrote it there so that if you were looking at it, you could see why I was moving on. So let's check this out in our head. I don't want you to do the distributive property for all these to check them, but I do want you to do it in your head. Well, 4 times 2 is 8, and then we get that x squared term. And then 4 times 1 is 4, and then x squared times x squared gives us 4x to the 4th. So we're good there. A lot of words being thrown your way here, so pause these videos and slow them down if you need to. We'll move on to the term on the right here because it's kind of uglier. So looking at these 3 terms, I guess this is kind of unfamiliar, and I'm looking at the numbers 18, 12, and 9. You know, I've had a lot of even numbers, so maybe I'm tempted to be thinking about the number 2 or 4 or 6 or something. But I really want to look at this 9 because this 9 is way more limiting than the others, because I know that 9 only has factors of 1, 3, and 9. And I'm looking for the greatest, so 9 doesn't go into 12, so I guess I'm crossing that out in my head. And I'm saying in my head because, you know, hopefully you're able to carry some of this with your working memory. If not, write this stuff off to the side. So then I move into 3. Well, 3 does fit into 12. It also fits into 18. So the greatest common factor of any of these values and the coefficients that I can pull out will really just be 3 pulled out to the left. I've totally dealt with my plain numbers, my regular constants, my coefficients of these different values, these different terms. Now I move on to the variables. I see an x, x squared, and an x. Of all these 3 terms, the most I can pull out is just one single x. I move on to the y. I see y squared, y, and y. The greatest number of y's that any of these 3 terms is just here, so that one would be y. I'm going to open up these parentheses, and I look at 3 times 6 to get 18. X, well, we've already factored that out completely, and then I'd be left with y. I move on to the middle term. 3 times 4 gives me 12. X times x gives me x squared, and then y times 1 gives me that y term. Now let's check that out in our head real quick. 3 times 4 gives me 12. X times x gives me x squared, and then y times 1 gives me y. Now if these are unclear, then make sure you're asking me questions about this. I'm moving on to the third and the final term in these lists of 3 terms, and I'm going to have 3 times positive 3 gives me 9. And then I've already factored out x and y, so there's that x, y. So I just stop right there. And I'm going to close those parentheses, and I scan through this part, and I make sure it looks complete. Sure enough, it does, and I'm completed with this problem. We can distribute the whole thing out to check it. Pause to give yourself a moment to verify that that's true. And then also, there's ways to, kind of double check some of these, with some shortcuts, but just sanity checks, like 3xy. Well, there's your xy. That's why it's plain out back here. Just try to look for patterns in all these as you do them. Now, these next 2, make them OYO problems on your own, but here's a little subtraction symbol there, and be on the lookout for that. I will pause the video now and show an answer. Alright, there are my answers if you want to pause it to give yourself time to do the checks. But if I look at this, 4 times 4 gives me 16 in A. 4 times B gives me 4B. And then I didn't check this one on the right myself on purpose. Maybe I'll even find an error in my work. Because, these kind of feel strange, especially as you throw these P's and Q's here. If you want, you could always rewrite them with x squared and then y instead. So 3p times p gives me that 3p squared. And there's my q. 3 times 3 gives me 9. P times, well, the absence of a p would give me 1p. And then q times q would give me q squared. Then I'm going to have this 3 times 12 to get 36. And then pq times 1 to get pq. Hopefully that's clear as I'm doing those checks and not too frustrating with all the marks. Really, without writing them all out, I don't want these to turn into 30-40 minute videos. So we have a new problem, factoring by grouping. Now, if you're unsure that you're ready to move on to a slightly different problem, then I would suggest hopping to a textbook or maybe tracking down some worksheets or seeking more practice like this from the teacher before moving on to this. Because unlike the last video where I was kind of going in speed mode in section 8.1, this is where you kind of want to slow down and check things out. Now, factoring by grouping means these are going to have 4 or more terms, and you're going to put different parts of the problem in groups. Now, that would really be a bummer if you had a term here, a term here, a term there, and a term here, and for some reason it made it easier to switch some around or whatever. But what ends up happening, hopefully, is that by the end of the chapter you kind of get a little bit of an eye for these things, and you realize what type of a factoring problem you're looking at. But keep in mind that by the end of by the end of a chapter test, really most of the instructions are just going to be a bunch of factoring problems, where you're only told to factor, and you're not sure which type of problem you're looking at. So these say factor each polynomial. So let's look at this. Maybe we can take the left two and treat them as a group, and the right two and treat them as a group as well. So let's see what happens. We're just going to factor the left two terms first. The left two terms have 4 in common, as well as b. So that's a 4b right there. And when I factor out 4b from the left two terms, I'm going to open up a parentheses, but don't forget, I'm only taking care of this portion. So there's 4b times a plus 2. Now I move on to these right two terms. So I'll, maybe box this to draw a little bit more attention to what I'm looking at. So of these two terms, it looks like I can take out a 3, leaving me with a plus 2. Now notice what we have going on here. We have a plus 2 showing up twice. I'm going to let you look at that for a moment. And now I'm going to pan down here, and I'm going to remind you of something. Whenever we had two terms that were alike, maybe we had 2x plus 3x, as long as this x had the same degree and the same variable, we could put 2 and 3 together to get x. But it's probably been so long that you've done these that you're just hopefully pretty confident in saying, well, 2 and 3 gives me 5. I'm good to go. Now, on purpose, what if I was like, well, guess what? X is really not just X. It's something in parentheses. But it's the same deal. Well, then there's really no reason why you couldn't pull a 2 and a 3 out of that same deal that would also be in parentheses. It just looks strange and it's something sort of new. And what I'm going to consider is that these a plus 2's, because they're the exact same thing in parentheses, these are really like terms. So that I'm having a plus 2 multiplied not just by 4b, but also by 3, and because of that, I can rewrite 4b plus 3 all times that a plus 2, because ask yourself this, is 4b being multiplied by a plus 2? Yes, it is. Is 3 being multiplied by a plus 2? Yes, it is. So therefore, 4b plus 3 can still be multiplied by a plus 2. And if you wanted, you could FOIL this whole thing out, first, outer, inner, last, and sure enough, you would get the same thing you began with. I would encourage you to do that if you feel uncomfortable with what you just saw show up. So we're factoring these polynomials. Now here's another point. It's kind of strange that we ended up with an a plus 2 on the left and an a plus 2 on the right. These are generally speaking going to all work out that way. And if not, it means one of two things. Either it's one of those very few problems that you can't factor, or you made a small mistake. So if you end up at a dead end, and you're not getting terms that match up, it means you messed something up and you need to approach it from a different angle. So just like the one on the left, we're going to treat the terms on the left as separate from the terms on the right. So let's look at this. We got 6x squared minus 15x. Between 6x squared and 15x, I can factor 3x, leaving me with 2x minus 5. Now notice that I'm talking about that one without explaining it, because by this point, the expectation is that you're comfortable with these. Now it looks like on this term to the right, all I can subtract is 4, which would leave me with 2x. And then I have to reverse the sign because I'm not factoring out a 4. I'm pulling a subtraction symbol out to the left. And so I really picture in my head this minus hitting that, changing the sign back to positive to make sure I'm not screwing this up. Now if you did have a plus sign, does 2x minus 5 match up with 2x plus 5? No, it wouldn't. So that might tell you to change your sign. But make sure that if that does happen, you're processing why it is the way it is. Now on purpose, I'm going to erase 3x and I'm going to rewrite it in a different color. And I'm going to do the same thing with this minus 4 here. So that instead, I can now see that 3x is being multiplied by the same thing. It's like terms again. So I'm going to write 3x minus 4, and then do 2x minus 5. And that's done, and you could FOIL this out. Try these two on your own by grouping, because I'm just going to show the solutions to these in about 5 seconds. Alright, now let me make a note of something here. You see how I have this minus factored out? Well, it would really be minus 1 times that, but I really dislike showing that. So that's where this s minus 1 comes from. So since you didn't have to listen to me work through these problems, I will make you listen to me do the checks. So here is s times r, same as rs. I'd have to flip the order of it. Here's 5s, there's my outer. Here's minus r, that's my inner. And here's negative 1 times 5 to give me minus 5. That one checked out just fine. Now I'm going to have to FOIL this one in my head. Here's 2x times 2x to give me 4x squared. And I don't have to carry much in my working memory there because I know that's the only way I'm going to get this squared term for this particular problem. Here's 2x and 8x, giving me 10x. Well, that's kind of weird the way they broke that out to begin with, but there's that 2x plus 8x. Maybe there's going to be a different way we can do problems like that later on down the road. Back up. And then here's 4 and 1 to get 4. We'll save doing these types of problems for the next video. And know this, these factoring problems are heading towards some sort of end result where we'll be able to actually solve equations where we have, polynomials that we begin with, like some sort of term, and then we have to factor it out, set it equal to 0, to figure out what's going on at certain points in the real world.